Hello everyone, my name is Zhi Yang. I'm a PhD student from Colorado School of Mines. So in the next 20 minutes, I'm going to talk about our work, titled as A Comparative Measurement Study of Web Tracking on Mobile and Desktop Environments. So here is the outline of this talk. I break it into 5 parts. In the first part, I will introduce you guys the background and motivation of this project. And next, I will introduce the design and implementation of our measurement framework. Following with that, I will introduce the data collection experiments and the dataset we derived. And next, I will introduce the measurement results analysis. And I will end this talk with some suggestions and conclusion. Okay, let's get started with the background and the motivations of this project. What is the background? We all know that web tracking happens frequently. It almost happens in every corner of the web. And correspondingly, web tracking measurement studies help people get a better understanding of web tracking in the wild. However, the fact is that little is known about web tracking on the mobile environment, especially on the mobile websites. So we decided to explore web tracking on the mobile websites and on the desktop websites. So why do we want to do that? So there are several reasons. First, mobile web browsing has been booming and overtaking the desktop browsing, according to a recent report. And second, some websites have mobile version web pages. For example, Facebook.com has its mobile version and desktop version web pages. Then the question could be, are the web tracking practices different between the mobile version of Facebook.com and the desktop version of Facebook.com? And thirdly, many web techniques, such as sensor-related ones, are mobile-specific. Then the question could be, could those techniques, specific to those mobile environment, be leveraged for mobile web tracking? So with this kind of background and motivations, we design and build this measurement framework as shown in this figure 1. We name it as WT-PyTrue, which is short for Web Tracking PyTrue. And the key component is over here, which is a browser extension. So in this extension, we instrumented 34 JavaScript APIs. So those APIs could be leveraged for web tracking according to the past research studies. So with this kind of instrumentation, any access to those APIs could be recorded. And besides, this browser extension can also record all the HTTP traffic during the page loading. And also all the event triggered during the page execution can also be recorded. So this is a feature of this browser extension, and this browser extension can be installed in a Firefox, mobile Firefox browser or desktop Firefox browser. This is a key component. And on the left part, we use automation driver to drive the mobile or desktop Firefox browser to visit a targeted websites. And as we just introduced, during each visit, this kind of data will be recorded. And then we have the last component, which is the data analyzer, to analyze the data we collected. So our framework uses real mobile device and a real mobile browser for data collection. Regarding this, you might ask, why not use an emulated mobile browser? Well, to answer that question, we did a pilot experiment. We visited 100 websites using a real mobile Firefox browser on a smartphone and using an emulated mobile Firefox browser on a desktop device. We found that 15 of those websites returned different web pages to those two browsers. So in other words, using an emulated mobile browser, you might have inaccurate data. And the second question you might have is that, is there any other option than using a real mobile device? Well, the answer is yes. OpenWPM Mobile is at least one option. Interestingly, This framework is released by the team of Dr. Guns Acker in this track. I believe he just made his presentation before my talk. So back to the framework again. We are using real mobile device and a real mobile browser. It's kind of a trade-off. I know it's relatively speaking, it's expensive since you are using a real device, but we don't want to put that much effort on configuring the emulated device, and we don't want inaccurate data for sure. With this background and the measurement framework being introduced, let's first see our data collection experiment settings. So we selected the homepages of 116K websites as our targeted websites. Specifically, they are the top 100K and the random 16K websites of the Alexa top 1 million site lists. And for all of those websites, the crawling settings are first, it is status. Second, we stay 20 seconds for each web page after page loading. And the third, after the page is loaded, the extension will automatically scroll down the web page in order to trigger and load those dynamic stuffs. And with the same targeted websites and the same crawling settings, we run the data collection experiments twice. We refer to them as experiment A and B. So in total, over 89,000 websites are successfully visited. From all the successfully visited websites, the next thing we did is selecting all the websites that have both mobile version and desktop version web pages. The reason we do this is because our goal is to explore the tracking differences between mobile websites and desktop websites. And to do that, we used proportional distance. It calculates the similarity between two web pages of a website. It is the ratio of HTML tag vector level Hamming distance over the total number of HTML tags appeared in the DOM tree. So for example, let's say we are visiting a website, and that website returns web page P1 to our mobile device, and returns web page P2 to our desktop device. And correspondingly, here are the two DOM trees of P1 and P2. With proportional distance, we can calculate the distance between those two DOM trees. And the value, it is calculated like this formally. The value of proportional distance is between 0 and 1. 0 means those two DOM trees are identical. The distance is 0, which further means that a website only has one version of web page. And the larger proportional distance value means that it's quite different between this DOM tree 1 and DOM tree 2, which further means that a website returns different stuff to different browser, like mobile and desktop. And which in other words, it means that that website has two versions of web page. Finally, we select 0.35 as the threshold. And in total, we have over 23,000 websites selected. So in other words, those websites, they have both mobile and a desktop version of web pages. The figure over here shows the distribution of these many websites in 6 ranking groups. So basically, we found that higher ranked websites are more likely to have both mobile version and desktop version web pages. So for example, among these top 1K websites, we found that over 36% of them have both mobile and desktop versions of our web pages. That means when you visit those websites, they will return your different web pages to your mobile browser and your desktop browser. So now we have the data set ready. So next, let's check and compare the tracking practices on those mobile websites and desktop websites in the dataset. In this section, I will present some interesting results about web tracking on mobile and desktop environments. So first, I will introduce the definition of a tracker in our work. A tracker is a fully qualified domain name of a third-party URL that would be blocked by adblock filter lists, for example, EasyList or EasyPrivacy. And we also divided those trackers into two categories. The first category of trackers are GS trackers. So those trackers, they use at least one GS API for tracking. And the second category of trackers are cookie trackers. So those trackers, they placed cookie for tracking purpose. The figures here present the distribution of all the GS trackers on the mobile environment and on the desktop environment. So the x-axis are the tracker index, and the y-axis on the left part is the number of first-party websites those trackers appeared on, and the y-axis on the right part is the number of JavaScript API accessed by those trackers. So in total, we identified over 4,000 GS trackers on the mobile environment and over 5,000 GS trackers on the desktop environment. We also observed the long tail phenomenon, like here. So most of the trackers in our dataset appeared less than 10 websites. And furthermore, we found that 13 common trackers among the top 20 lists, they are shared between mobile and desktop environment. In other words, those trackers, they are dominating both mobile environment and the desktop environment. The Venn diagram over here shows the relationship between the 4,000 GS trackers identified on the mobile environment and the 5,000 GS trackers identified on the desktop environment. So overall, we found that over 3,000 of them are shared between those two environments. However, we also found there's a large number of mobile-specific GS trackers. Like here, we identified over 700 of mobile-specific GS trackers. For these mobile-specific GS trackers, we wondered who are they and where are they. To investigate this, we leveraged 4 data sources. They are Crunchbase, TeamLabs library, TIS certificate, and Whois record. So in total, we found 382 unique organizations that host these mobile-specific GS trackers. Here, this table summarizes the top 10 organizations. Interestingly, we found that five of them, those brown ones, are all CDN services provider. And the rest, 5 blue ones, are all domain management service provider. So in other words, those organization names are not the real one behind those trackers. It's just one approach those trackers adopted to hide themselves from the public. So in other words, we found that those trackers, they tend to use CDN services and tend to hide themselves from the public. So regarding the countries of those GS trackers, we found that United States is the top 1 country that has the most mobile-specific GS trackers. Now let's check some facts from the perspective of first-party websites. So first, we did a binomial proportion test. The result indicates that desktop version websites are more likely to have more GS trackers. And second, as you can tell from those 2 sub-figures, home category websites on the mobile environment has the most trackers, while the news category on the desktop environment has the most trackers. And besides this, we found that tracking occurs more intensively on the higher ranked websites for both mobile environment and desktop environment. So far, we have talked about GS trackers. Now let's talk about cookie trackers. So in this part, we only analyzed ID cookies placed by them. And ID cookies those cookies can be used to track web users. And in total, we identified over 4,000 cookie trackers on the mobile environment and nearly 5,000 cookie trackers on the desktop environment. Here, those two figures present the top 20 trackers on the mobile environment and the top 20 trackers on the desktop environment. So the x-axis is the trackers, and the y-axis on the left part is the number of first-party websites this tracker placed cookie. And the y-axis on the right part is the number of cookies placed by this tracker. Yeah, so as you can see from these figures, hkn.com, which is owned by Newstar, and adserver.org, which is owned by the Trade Desk, placed cookies on the most first-party websites. And the purpose of those cookies is targeted advertising. From the perspective of first-party websites, we found that websites on the desktop environment are more likely to have more cookie trackers, according to our statistical test. This observation is identical to what we observed for the JS trackers. And here the figure shows the lifetime of those ID cookies on the mobile environment and on the desktop environment. We found that the lifetime distribution are similar. And beyond that, we found that 80% of the ID cookies have a lifetime longer than 52 weeks. So there are several implications from those results. First, web tracking on the mobile environment is almost as prevalent as that on the desktop environment. However, we think the potential impact could be more severe, especially when you're considering how people use their smartphones in their daily life. Second, top trackers, they are dominating on both mobile and desktop environment. Third, the large amount of those long-tail trackers should never be neglected. In other words, they are huge. And lastly, and unfortunately, we web users suffer the information asymmetry that we know few about those trackers, while those trackers learn a lot of us. So from what we observed in this study, we tentatively give some suggestions to different groups of people. For the first group, web users, the most important thing is to improve the awareness of web tracking and user privacy. And second, we suggest some web users to use ad blockers to protect themselves from being tracked. And for developers, we hope they can bring web users with data transparency. And they also should act in accordance with the professional ethics, like respect the user privacy. And for researchers, we expect to see some improvement on the filter list, which is one research direction. Some people use machine learning to improve the performance of filter lists. And we also would like to see some web tracking defense techniques to be proposed and to better protect web users. So in conclusion, we designed and built a measurement framework named WT-by-True. Using WT-by-True, we conducted a comparison study of web tracking practices on the mobile environment and on the desktop environment. And we found that mobile web tracking has its unique characteristics, especially due to the mobile-specific trackers. That's pretty much all of my talk. Questions are welcome. Thank you, guys.